Hi everyone, today we'll be looking at a free room on TryAcme. It is based on networking so that we can continue the networking learning path. Firstly, we have to search for the room. Go to learn, search, then we type networking. Networking. Okay. Then we'll feel okay, we have it already. What is networking? But for others' sake, you can just filter. It's a free room, free only, and the difficulty is easy. So we have introductory networking. So these are all the free rooms that have to do with networking. So we click on this. This is the room we're interested in, and because I'll be using the attack box later and it kind of takes time to run the attack box, the moment I'm at the TCP IP model, I'm going to start the attack box so I don't waste compute resources. Now this is an introductory room. It's going to give an introduction to networking theory and the basic networking tools. Let's get started. The aim of this room is to provide a beginners an introduction to the basic principles of networking. Networking is actually a massive topic, so this is just a brief overview. It takes more than what is in this room to grab it. So the topics that we are going to cover in this room are the OSI model, the TCP IP model, how these models look in practice, and an introduction to basic networking tools. Let's get started. The OSI model. OSI means Open Systems Interconnection, and the OSI model is a standardized model which we use to demonstrate the theory behind computer networking. In practice, it's actually the more compact TCP IP model that real-world networking is based off. However, the OSI model in many ways is easier to get an initial understanding from. So we have two models, the OSI model that helps understand the concept, and the TCP IP model, which is the one that is being implemented physically. The OSI model consists of 7 layers. We have the application layer, presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. Now that you remember all these, there are different mnemonics that you can use. I personally favor do not throw sausage pizza away. Please do not throw sausage pizza away. Here we have anxious pale Shakespeare, treated nervous drugs patiently. So you can actually go online and find the one that resonates with you and you can use it. We are starting from the top, layer 7. This is the application layer. It essentially provides networking options to programs running on a computer, and it works almost exclusively with applications, providing an interface for them to use in order to transmit data. When data is given to the application layer, it is passed down to the presentation layer. Presentation layer is layer 6. This layer will receive the data from the application layer, and it will be sent in a format that the application understands, but it is not necessarily in a standardized format that could be understood by the application layer in the receiving computer. Now what this means is that the application itself is different from the application layer. The application layer is just like the concept that the application used to work. How do I put this now? Okay, let's say we have an application called A. Now A is the application that we interact with ourselves, right? However, behind that A, there is an application layer that is implemented for networking. So that's just what it means. So the presentation layer just interacts with the application. It will use a format that the application understands once it receives the data from the application layer. So it's like application layer of the application here. Now it will now process in a format that is only the application that understands, but not necessarily the application layer. That's what it means. The presentation layer will translate the data into a standardized format, as well as handling any encryption, compression, or other transformations to the data. With this complete, the data is passed down to the session layer. Layer 5 is the session layer. When this layer 5 receives the correctly formatted data from the presentation layer, it now looks to see if it can set up a connection with the other computer across the network. If it can't send it, then it sends back an error, and the process goes no further. If a session can be established, then it is the job of the session layer to maintain it as well as cooperate with the session layer of the remote computer in order to synchronize communications. We have two computers, computer A and computer B. They both have applications on them, and computer A is trying to communicate to computer B. So what the session layer is the one that sets up the connection and maintains that connection and ensures that they are in sync. If there is no connection established, it will send back an error. But if a connection is established, communication is allowed to occur. So the session layer is particularly important as the session that it creates is unique to the communication in question. This is what allows you to make multiple requests to different endpoints simultaneously without all the data getting mixed up. So you think about opening multiple tabs in your web browser, and whatever you send to browser, the tab A, tab B, every session is maintained. You don't get anything mixed up. So that's like what the session layer does. When the session layer has successfully logged a connection between the hosts and the remote computer, the data is passed down to the transport layer. Layer 4, transport layer. The transport layer is a very interesting layer that serves numerous important functions. Its first purpose is to choose the protocol over which the data is to be transmitted. And the two most common protocols in the transport layer are the TCP and the UDP. The TCP means Transmission Control Protocol, and the UDP means User Datagram Protocol. With TCP transmission, the connection is connection based. That means you have to establish a connection between the two computers before communication can occur. Now, this allows for a reliable transmission as the connection can be used to ensure that the packets all get to the right place. A TCP connection allows the two computers to remain in constant communication to ensure that the data is sent at an acceptable speed and that any lost data is resent. With UDP, the opposite is true. Packets of data are essentially thrown at the receiving computer. If it can't keep up, then that's its problem. So it's like for TCP, you have to make sure that the computer that is receiving and the computer that is sending, they've established a connection and is capable of receiving whatever data is being sent. For UDP, it's connectionless. That means it doesn't care whether the receiving computer has established a connection. It just sends it. Now, whether the receiving computer gets all the data, some of the data, or no data at all, it's the receiving computer's problem. So what this means is that TCP would usually be chosen for situations where accuracy is favored over speed, such as the file transfer or loading a web page, and UDP will be used in situations where speed is more important, e.g. video streaming. With a protocol selected, the transport layer then divides the transmission up into bite-sized pieces, and over TCP, these bite-sized pieces are called segments, and over UDP, they are called datagrams. This makes it easier to transmit the message successfully. Layer 3, network layer. This layer is responsible for locating the destination of your request. For example, the internet is a huge network, and when you want to request information from a web page, it is the network layer that takes the IP address of that page, figures out the best route to take. So at this stage, we are working with what is referred to as logical addressing, that is the IP address, which are all software controlled. Logical addresses are used to provide order to networks. It categorizes them and allows us to properly sort them. And currently, the most common form of logical addressing is the IPv4 format, which we are all likely familiar with. So we have the 192.168.1.1. Now we move to the data link layer. The data link layer is layer 2, and it focuses on the physical addressing of the transmission. Now you may wonder, what is logical addressing, what is physical addressing? Okay, we'll get to that soon. Now it receives a packet from the network layer that includes the IP address for the remote computer, and it adds in the physical, that is the MAC address of the receiving endpoint. Inside every network enabled computer, we have what we call a network interface card, and this network interface card will come with a unique MAC address. MAC address is media access control. This media access control address is used to identify it. MAC address are burnt by the manufacturer, like they're actually burnt into the card. You can't change them, although they can be spoofed. And when information is sent across a network, it is actually the physical address that is used to identify where exactly to send the information. Additionally, it is also the job of the data link layer to present the data in a format suitable for transmission. The data link layer also serves an important function when it receives data, as it checks the received information to make sure that it hasn't been corrupted during transmission, which could well happen when the data is transmitted by layer 1, the physical layer. So the logical address is the IP address. Okay, so let's take, for example, you're at home, I'm at home, we're all at home. So where we are physically, that spot, that address, that's a MAC address. No matter what, whenever we are at home, that's our MAC address. Now when we now like interact with the internet, right? That's the IP address. So just the same way, like you have a computer now, that computer has had a permanent imprint on it. Wherever you go, however you go, that MAC address, it is MAC address. But there is the IP address that changes. That's the logical addressing, because it's still the same laptop, but you're in a different location. Exactly the same way your DNA goes with you everywhere you are. Even if you are not on this planet, it's still your DNA. However, because your location has changed, you are having another address, but your DNA does not change. Exactly. So physical layer. The physical layer is right down to the hardware of the computer, and this is where the electrical pulses that make up data transfer over a network are sent and received. It is the job of the physical layer to convert the binary data of the transmission into signals and transmit them across the network, as well as receiving incoming signals and converting them back into binary data. So that's just the physical layer, is all the wiring that you have, the cables and everything that makes the networking. Now for the which layer questions below, answer using layer number, that is 1 to 7. Okay, let's start answering questions. Which layer would choose to send data over TCP or UDP? That's layer 4, and that's the transport layer. So layer 4. Which layer checks received information to make sure that it hasn't been corrupted? That will be layer 2. Okay, that's the data link layer. It serves an important function when it receives data, as it checks the received information to make sure that it hasn't been corrupted during transmission. So we have layer 2 here. In which layer would data be formatted in preparation for transmission? That's also layer 2. Which layer transmits and receives data? Layer 1. Which layer encrypts, compresses, or otherwise transforms the initial data to give it a standardized format? That's layer 6, the session layer, when it's trying to interact with the application of the receiving computer. Which layer tracks communications between the host and receiving computers? Still layer 6. That should be layer 5. Which layer tracks? Is that not the session layer? Let's see. Okay, yeah, layer 5, session layer. Which layer accepts communication requests from applications. When you have applications, then that's the application layer. Which layer handles logical addressing? That should be layer 3. We'll talk about network. When you're sending data over TCP, what would you call the byte-sized pieces of data? They're called TCP fragments, no segments. What would you call the byte-sized segments? They're called segments. Which layer would the FTP protocol communicate with? Well, it's a file transfer protocol, and that will be layer 7. Communicates with the application layer. But you can actually do your research. You just transfer data between computers, often accept file. That's layer 7. There are different protocols for each layer. Which transport layer protocol would be best suited to transmit a live video? UDP. Yeah. So that's that about the second task. The encapsulation layer. Sorry. The process of encapsulation, rather, as the data is passed down each layer of the model, more information containing details specific to the layer in question is added on to the start of the transmission. As an example, the header added by the network layer would include things like the source and the destination IP addresses, and the header added by the transport layer would include, amongst other things, information specific to the protocol being used. The data link layer also adds a PSON at the end of the transmission, which is used to verify that the data has not been corrupted on transmission. This also has the added bonus of increased security, as the data can't be intercepted and tampered with without breaking the trailer. This whole process is referred to as encapsulation, the process by which data can be sent from one computer to another. So at the application layer, its own header is added. Same applies to the layer 6, 5, 4, 3. Then at layer 2, we have the header and the trailer. Then layer 1, we have the bits, right? So you notice that the encapsulated data is given different names at different steps of the process. For 765, we call it data. For 4, we call it segments or datagrams, depending on the protocol that is being used. For 5, we call it packets. 6, we call it frames. And the stage 7 is called bits. So now, when the message is received by the second computer, it reverses the process by starting at the physical layer and working up until it reaches the application layer, stripping off the added information as it goes. This is referred to as the encapsulation. As much as you can think of the layers of the OSI model as existing inside every computer with network capabilities, why it's not actually as clear-cut in practice, they all follow the same process of encapsulation and de-encapsulation. Now, these processes are very important, not just because of their practical use, but because it kind of gives a standardized method for sending data. This means that all transmissions will consistently follow the same methodology, allowing any network-enabled device to send a request to any other reachable device and be sure that it will be understood. Regardless of whether they are from the same manufacturer, they use the same OS, or any other factors. So this is just a way to make sure communication is actually communication, it's occurring. We use the same protocol, the same method. Doesn't matter the manufacturer, doesn't matter the operating system, doesn't matter the location, whatever it is. Communication is still established. So how would you refer to data at layer 2 of the encapsulation process? This is layer 2, and data is referred to as frames. At layer 4, this is layer 4, it's called segments or datagrams. So how would you refer to data at layer 4 of the encapsulation process with the ASI model if the UDP protocol has been selected as datagrams? What process will the computer perform on a received message? That's the encapsulation. Which is the only layer of the OSI model to add a trailer during encapsulation? That's the data link layer, layer 2. Does encapsulation provide an extra layer of security? Yes, definitely. Now we move to the TCP/IP model, and like I said earlier, this is the one that is in use practically. OSI model is just for us to understand the concepts. That's just theory. So the OSI model is actually very similar to the TCP/IP model is actually very similar to the OSI model, and it is a few years older than the OSI model, and it serves as the basis for real-world networking. The TCP/IP model consists of 4 layers. We have the application layer, the transport layer, the internet layer, and the network interface. And they'll actually cover some ranges of layers from the OSI model. Note, some recent sources will split the TCP/IP model into 5 layers. So they break the network layer into the network interface layer into data link and physical layers. So if you're asking why we bother with the OSI model if it is actually not used for anything in the real world, it's just that the OSI model is less condensed and more rigid than the TCP/IP model, so it is actually very easy for learning than the initial theory of networking. So this is how the the models match up. You can see that for the OSI model we have the layer 7, 6, and 5 that has been condensed into the application layer of the TCP/IP model. Transport is transport, network is internet, and the network interface we have the data link layer and the physical layer of the OSI model. So the process of encapsulation and decapsulation also work exactly the same way with the TCP/IP model, and at each layer of the TCP/IP model a header is added during encapsulation and it is removed during the encapsulation. Now let's get to the practical side. So now we're going to talk about how the TCP connection is established. Okay, now we have a layered model is a great visual aid. However, it shows us the general process of how data can be encapsulated and sent across a network. But how does it actually happen? So when you look at the TCP/IP model, we can think of it as a table with 4 layers. But we are actually talking about a suite of protocols, that is set of rules that define how an action is to be carried out. TCP/IP model takes its name rather from the 2 most important of its layers. We have the transmission control protocol and the internet protocol, right? So the TCP is the one that controls the flow of data between the 2 endpoints, and the IP is one that controls how packets are addressed and sent. There are many more protocols that make up the TCP/IP suite, and we'll cover them later. But for this task, we are looking at TCP. And as I mentioned earlier, it's a connection-based protocol. That means before you send any data via a TCP, a connection must be established between the 2 computers. And when you attempt to make a connection, this is how it happens. The computer that wants to establish a connection will first send a special request to the remote server indicating that it wants to initialize a connection. Now this request will contain something called a SYN bit that is synchronized, which essentially makes first contact in starting the connection process. The server will then respond with a packet containing the SYN bit as well as the ACK bit. The ACK bit is acknowledgement bit. Now finally, the computer, that is my own computer, will now send a packet that contains the ACK bit by itself. confirming that the connection has been set up successfully. It is called the three-way handshake. We have the SYN arc, and the ARC. The three-way handshake. And data can be reliably transmitted between the two computers. Any data that is lost or corrupted on transmission is resent, thus leading to a connection which appears to be lossless. So we have a diagram representing that, and we have my way the best of Frank Sinatra. I think that's supposed to be a joke, right? So we're not going to go into exactly how this works, but it is sufficient to know that three-way handshake must be carried out before a connection can be established using TCP. So just a brief history. It is important to understand exactly why the TCP IP model and the OSI model were created. To begin with, there was no standardization. Different manufacturers followed their own methodologies, and consequently, systems made by different manufacturers were completely incompatible when it came to networking. So the TCP IP model was introduced by the American DoD in 1982 to provide a standard, something for all of the different manufacturers to follow. This sorted out the inconsistency problems, and later the OSI model was also introduced by the International Organization for Standardization. However, it is mainly used as a more comprehensive guide for learning. The TCP IP model is still the standard upon which modern networking is based. What this is saying is that before, if you had devices from a manufacturer, let's say HP, it can't communicate well, it can't network well with device from Dell or from Apple. So that's just what it means. So they had to come up with this standard that all manufacturers will follow so that there can be interoperability. Which model was first introduced? That's the TCP IP. Which layer of the TCP model covers the functionality of the transport layer of the OSI model? That's going to be the transport. Still the same. Which layer of the TCP IP model covers the functionality of the session layer of the OSI model? That's going to be the application, since it covers all three. Covers layer 7, 6, and 5. The network interface layer of the TCP IP model covers the functionality of two layers in the OSI model. These layers are data link layer and the physical layer. Please do not throw FHPs away. Which layer of the TCP IP model handles the functionality of the OSI network layer? That's going to be the internet. What kind of protocol is TCP? That's a connection-based protocol. Connection-based. What is SYN short for? That's synchronize. Synchronize. What is the second step of the three-way handshake? That's SYN and ARC. What is the short name for the acknowledgement segment in the three-way handshake? ARC. Now with this, we are done with the models, networking models, the TCP IP model and the OSI model. In the next class, we'll be looking at the common basic networking tools that are in use. Thank you very much for listening. If you have any question, you can put it in the comments section and we can try to find answers to your questions. Thank you very much.